Support us by subscribing, ring the notification bell, press all, and thumbs up.
The idea of PTG is to have a device that sees what you see, it hears what you hear, and it's there to help you, sort of like a co-pilot, walk you through steps of a complex procedure, make sure you do them correctly, basically help you do a complex physical skilled task better. DARPA is involved because it fills a really necessary military need. How are we going to do more without an infinite amount of training? DARPA is in a position to do it because we're at the cutting edge of both augmented reality and artificial intelligence. So the technology is sort of marrying artificial intelligence, so it's think of an agent, with augmented reality. So that you've got a device that is really helpful in letting you do things in the real world. When your hands are in the middle of something and you've got to figure out what the next step is. And so it's this interactive two-way audio-visual help that we're looking to add. We're really focusing on, one, battlefield medicine. When people get hurt, we want to get them safe and keep them healthy. Sustainment, by which we mean the people who are responsible for keeping the Air Force in the sky, the tanks rolling, the ships sailing. And thirdly is what we call co-piloting, specifically looking at helicopters. We're navigating, we're communicating, all these other complex tasks. So those are the three specific things we're focused on. But I want to be clear, I think all those three are important, but I think they're just scratching the surface. There are so many military specialties that could be improved with this kind of help. Today I'm talking to you here from the Hacker Reactor at MIT. We're being hosted by Lincoln Labs, who is one of the evaluators for this program. So what we have around the reactors are different sets of teams. They're using different hardware, they've got different approaches, but they're all showing their first versions. And the idea is partly for us to see their progress, but also for all of them to work together so we get this sort of cross-stimulation of groups working with each other. So this may surprise people, but the demos right now are designed to do cooking. We're giving people cooking recipes. Cooking actually is a really good example of a complex physical task that can be done many ways. There are lots of different objects, solids, liquids, things change state. So it's visually quite complex. There's specialized terminology, there are specialized devices, and there's a lot of different ways it can be accomplished. So it's a really good practice domain for all kinds of other highly skilled tasks. We also have members of the end user communities to come in and sort of look at these early stages of this technology, give user feedback, right? Make sure we develop the technology to solve these very real needs, and at the same time hopefully get an idea of where the technology is going so they can bring that back to their leadership with regard to what future possibilities are.
The application I'm looking at is medical simulation for training. We definitely need to come up with systems that are objective and repeatable to get away from the subjective see one, do one, teach one model that all medicine uses. We need a system that's accurate enough to eventually make judgments on the competency and possibly be used for long-term longitudinal observation of the evolution of the individual medics and providers.
This is a really difficult task and this is a challenge, but not only are the performers meeting it, but I've got performers showing up early. So, for example, no one was supposed to have to do the battlefield medicine task yet, and yet we've already got performers out doing battlefield medicine tasks, so that's great. So the excitement in the community and the sort of rapid pace of the community, I'm really impressed at how quickly people are making progress